Okay, what we have here, this is an antigen presenting cell. And on the antigen presenting cell is MHC, major histocompatibility complex. MHC is going to have gotten a little something from a microbe of some kind, an antigen or whatever. And the MHC is going to bind to a T cell receptor on a T cell. And when it binds, you're going to have either a CD4 or a CD8 that are going to also kind of hook on to this MHC. And at the same time, you're going to have a co-stimulator on the T cell, which is going to be a CD28, which is going to bind to a B7 on the antigen presenting cell. And that's going to be what allows this to happen, I guess. So going back here. So first of all, the MHC TCR bind. That binding also happens in concurrence with a CD4 or a CD8 binding. The CD4 or CD8 binding activates something called LCK on the CD4, the CD8. The LCK being activated then is going to activate the tyrosine on the CD3, which is this guy right here, and also the tyrosine on the zeta chain over here. The zeta chains are non-covalently bound to the alpha and beta chains on the TCR, and the alpha and beta chains on the TCR are covalently, through a disulfide bond, bound to each other. So these are bound to each other, the alpha and beta chains of the TCR, non-covalently bound to the zeta chain, which is this green squiggly. Also over here, the lambda and gamma chains on the CD3 are non-covalently bound to each other as well. So anyway, going back, binds, activates LCK, LCK then activates tyrosine. Tyrosine now is going to undergo on the zeta, you have the ZAP. What does ZAP stand for again? I don't remember. ZAP 70. The ZAP 70 is going to do something, but first I should probably point out that when this process here was activated, the tyrosine, that there's something called ITAM and an ITIM. The ITAM is the thing that activates the further, it's a something activation molecule, and the ITIM is an inhibition molecule. So the ITAM is going to be the thing that's activated here, which is going to allow this to move forward. So that does the ZAP 70, which is associated with, it's like a zeta associated protein or something like that.
Yes,
70,
that's exactly right.
Zeta associated protein. And it ends up then activating these three things, which is the phospholipase C, PLC gamma 1, the phosphatidyl tri, and also, I don't remember, PI3, I memorized it earlier, don't anymore, or the MAP kinase, okay, or actually all of them. So these two guys, the PLC gamma 1 and the inositol triphosphate, that's what it is, PI3, inositol triphosphate, are going to activate the calcineurin, and the calcineurin, which is a calmodulin activated molecule, is going to activate through dephosphorylation the NFAT, which stands for nuclear factor of activated T cells, and that is going to lead to the activation of the IL, interleukin 2 gene, which causes inflammation. So if we wanted to stop this process here, we would take immunosuppressive drugs, cyclosporin, tacrolimus, or sirolimus, which have an inhibitory effect on calcineurin. and that would slow this process down here. At the same time, going back here, that this ZAP70 is activating, these two guys. It also activates something called MAP kinase. MAP kinase is associated with RAC and RAS, which has this whole process of steps. It also leads to IL-2 gene activation. And then separately, we don't understand how it connects yet, we also have phosphokinase C, which activates IKB kinase. And IKB kinase interacts with this little molecule here, the NF-kappa beta. He has this little IKB inhibitor stuck to him, and he doesn't work unless this IKB inhibitor is off. So the IKB kinase knocks the IKB inhibitor off of NF-kappa beta, which causes this NF-kappa beta to be activated, and the NF-kappa beta is going to cause the gene activation of IL-2.